Welcome back to LIS 4273 Advanced Statistic and Analytics. I prefer Introduction to Statistic and Analytics using R. Again, my name is Alon Friedman, Dr. Friedman, and we are in fall 2020, and I hope you read the syllabus and understood what is your obligation and what is my obligation to you. So let's start with statistics. The objective of statistics is the primary idea that we can do better than the average. And this is the formula, and we will learn about formula throughout the semester. So what is basically statistics? Statistics is often defined as a group of methods used to collect, analyze, present, and provide interpretation to the data to help make better decisions. So why do we need statistic analytics? Is the idea that using to analyze the data will help us to better understand, first of all, the data, evaluate what is entailed, and assist to formulate alternative course of action, which means that if a product does not sell so well, or if our audience do not like a new design, we will take some action that will hopefully improve the performance. So for me, one of the things that statistics and analytics often address is curiosity. I'm always like to learn more about the data, what it really means, and statistics and analytics give me the platform to do that. In Introduction to Statistics, the course that you took, you learned about descriptive statistics and inferential statistics. We learned that in descriptive statistics, we usually collecting, summarizing, and describing the data. In inferential statistics, we draw conclusion and make decision concerning the population based on a sample data. And I will explain what is a sample versus the entire population. So descriptive, as you are all familiar with, is the idea of collecting the data, presenting the data, and try to catch the average or to ability to summarize the data that will make more sense. In inferential statistics, we are all about estimate the population mean using the sample mean weight in order for us to better understand. We often see in that platform or this method is the idea of hypothesis. We test the claim that the population mean weight is 120 pounds. So we draw conclusion, we take the sample, we measure that, and we are trying to conclude that based on a sample that match the population, we can assume that the population is basically, his weight is 120 pounds or more or less. So in statistics and analytics, we often usually see three paradigms. The first is, as you learn, descriptive statistics. The second is inferential statistics. And we will also, in this class, we will also look very closely in predictive analytics, which means time series, predicting, modeling, and analytics in order for us to better understand the structure of the data. But before we will start talking about all those elements, I need to start with basic definitions of what we are going to use again and again throughout the semester. Measuring is the key statistical research that shows the relationship between the data and the observation. A population is the collection of all the items or things under consideration. A sample is proportion of the population select from the analysis. So this is part of the terminology that we will use again and again throughout the semester. Population versus a sample, and the methodology that we apply in order for us to find. So in the population, we usually talks about the entire premises of the analysis. And in sample, we usually call it statistics because we are trying to test if the hypothesis is true or false and to compare it to the entire population. So the population consists of all the items, and usually the population is being studied is also called target population. For example, in USA, every 10 years, the US government gathers information from the entire population. You probably hear that from the news, and what is it consists. If you are allowed for the government to register you as part of the population, even though if you do or do not have American passport. And since the entire population is sample, it refers to a census, and this is something that often used in order for us to do that. The term sample refers to the process of choosing a sample of elements from the total population. So the reason why we take a sample is it is less time consuming, it is less costly, meaning that we can conduct a sample very fast. And that's what we're going to see in this semester, that every news organization and every party and every politician will take a sample in order for them to judge where they're standing with regard to their popularity. And it is very practical because we can reject or examine that in the population itself. There is two types of samples: non-probability sample and probability sample. And this is, again, I want you to think how we're going to make sure that if we are going to take a sample, what is the reliability and validity of the sample? And this is something that is really a concern when we are talking about data and a large set of data. So the sample, the non-probability, it's more subjective. It is based on a judgment, based on convenience. In comparison, the probability sample is based on simple random, cluster or systematic, and it is a methodology that we are obligated to follow in order for us to report on the sample success or failure. So let's go over the sample procedures, and it's very simple. A simple random sample is that every individual or item from the frame has an equal chance for being selected. The selected may be with a replacement or without a replacement, and I will talk about that later on in the course itself. And the sample obtained from the table of random number or computer random number generator. And I'll show you how to do that, and we will talk about that later on. Systematic is basically we decide on the sample size, which is n, lowercase n, and we divide the frame of capital N individual into the groups of k, and we divided k equal capital N divided by n in order for us to select how we're going to do that and how we apply that. So it is very systematic and very has a methodology that we need to follow. The same one is the next methodology, certified sample, which we divide the population into two or more subgroups, also called stara, and according to some common characteristics. Example, age. Example, income. Example, brand of the car that we drive. Those are the example of the characteristics that we look at, and a simple random sample is selected from each subgroup with a sample size population with the subgroup data size. So we will make the comparison in order for us to evaluate and to verify it. Cluster is another way for us to classify the population, and it's based on dividing into several groups or several large groups into it, and we try to divide the population to different groups, example 16 clusters, and we take from the cluster itself, we take a sample, a random sample of cluster in order for us to apply and to measure it. So those are the advantages and a disadvantage of a sample. In simple random sample and systematic sample, it is simple to use, maybe a good good representation of the population that we are trying to study. Stratified sample ensure that representation of the individual across the entire sample is a key component to its strength, and cluster sample is more cost efficient, less efficient, need a larger sample to require the same level of precision. The same now goes to the data, and we have different types of data. We have primary data and secondary data. What does it really mean? When we are talking about primary data, we are talking about actually going out and observe or survey or do an experiment in order for us to find what is actually happens. In secondary data, we collect from secondary sources, example print, or example social media, example Twitter. And so it is secondary, it's not on observation and what we saw, what happened. So this is something that you need to be aware of, because statistics usually likes to organize or classify or define each source of data and what is the premises of the data, what is the strength of the data, and what is the weaknesses of the data. It's part of the terminology that we need to be aware of. With regard to types of data, we usually divide the data into two types: categorical data and numerical data. Example of categorical data: married, are you married, yes or no? Or political party identification, are you Democrat or Republican? Or the color of your eyes, do you have blue eyes or you have green eyes or red eyes? It doesn't really matter, but this is way for us to categorize the data, and the data can be easily categorized. Numerical has two subcategories: discrete versus continuous. Example for discrete is the number of children. We can count the number of children someone has as a way for us to measure how we're going to classify it and organize it. So this is something that we often use. Continuous is weight. Example, today I weigh 400 pounds or 200 pounds or 100 pounds because I was sitting here all day recording this session and I was eating or did not eat at that time. And so this is something that weight change all the time, and as we are experienced, this is not a steady number. Today I weigh 200 pounds, but maybe tomorrow I will weigh 120 because I will stop eating the ice cream that I have in the refrigerator. So this is a continuous, and it's not solid, and this is a number that stick with you to the rest of your life. In compared to discrete, the number of children is that when you have children, they will not vanish. They will always remain the same number, even though you might add more children to your family. So it's more consistent. In compared to weight, it can be bounced around. Level of measurements and the scale, as we see, we have the data itself. We have numerical data, which has no categories or no order or direction, which is the lowest level. We have next level is the ordinal data, which has ordered categories, but no real zero. We have interval data, difference between the measurements, but no true value. In this case, interval can be 1, 2, 3 in compared to ordinal data. But the highest level, and this is where we have a true zero, we have something that we actually can scale and say, okay, if you got an A, this is a ratio number, and if you got 0, this is the ratio of the data that we can organize and understand. Most of the textbooks in statistics talk about element or number. So I need to define that because part of the definitions will help you to sort data that you will find online with regard to data science. So example is a person, a firm, a country, etc. A variable is the characteristic under study. Example, male or female, or income, or education, or age. And a data set is a collection of observation on one or more variables intel. So I hope that will give you some directions of how we're going to conduct in the terminology we're going to use in this class. We are going to be very specific. It's not going to be generic or descriptive. It's going to be very focused and very determined how we're going to describe the things. Usually, another two terms that we often use is quantitative variable that is measured numerically and discrete variable versus continuous. If a variable can take on any value between two specific value, it's called continuous. Otherwise, it's called discrete. Example, suppose you flip a coin 2 times. The simple experiment has 4 possible outcomes. Now, let random variable x represent the number of heads that result in this experiment. And this case, it is more discrete because that's how the process applied to. Continuous, in example, again, the issue of weight, 150 versus 250, but the weight is always changing, and we are something that we always fight against it, trying to monitor our weight in order for us to be healthy. Other terminology, cross-section versus time series. Cross-section is defined as the data collected from a different element at the same point in time for the same period of time. Time series is defined as data collected on the same element for the same variable at different points of time. And this is something that we will see again and again, how we're going to see the time series modules, theories, and modules, how they apply to it. And the last issue is the idea of a sum notation and how we apply to it and how to accommodate that into our analysis. So, as you know, I'm also very fond of visualization, and this cartoon is from A Guide to Statistics, and it is a very fun textbook that is based on cartoons. And so I want you to understand that one of the things that we often will judge ourselves is, can we measure, or why cannot we measure this data? And this is part of the essence to it. So, as I told you before, I'm a big fan of R. And what is basically R? Most computer software is basically proprietary software. It owns to a company or individuals. And usually the source is always kept secret and we do not have access to it and we cannot modify or examine the data itself. Then there was a movement during 1970 that called open source software. This movement has a long history and it came up with a browser, its own, and a lot of software such as Linux, that is operating system, that allowed user to modify and to adjust it in compared to what we have with regard to Apple or Microsoft or Google platform that is usually standard and we cannot modify it or we cannot take advantage of it. Example of open source are as the Mozilla Firefox browser. Apache is again one of the platforms that runs web servers in the world. PHP is a programming language, and all of that is part of the open source environment and how they change the online environment and technology with that regard. So what is R and why are we learning it in statistics and analytics? To some people, R is just the 18th letter of the alphabet. To others, is the idea of ranking movies, but it is much more. R is the open source platform, and it is established in 1976 and at Bell Labs, which does not exist anymore. It's now under AT&T. And in that time, they started a project. A technician by the name of Chambers started a project that he tried to achieve applying statistics in open source environment. It never came through. It never opened up because Bell Lab had difficulties with regard to money, and in that time he called John Chambers called it S language, but it never opened up. In 1995, Ross Ilka and Robert German from the University of Auckland opened up the open source and call it an R. They call it because R is based on their first name, Ross and Robert. And so R basically is every data manipulation statistical model and ability to create our own module or to test module that we can apply. The issue here is that we have the open idea that we can modify the coding, we can apply it to statistical analysis, and what we have is an environment that invites us to contribute. Why is that? Because one of the things that R is so good at is that we are creating packages that are in the end will be free for everyone to use, and it's basically invite people to apply what we develop. And so this is how I see data science. We analyze data, large set of data, and we invite people to join in and to analyze our data. This is why most of our publication or most of our work is basically open to everyone to see and to develop their own. And so the R language is basically the idea of interpretation of the language is usually common in a line command, and it usually has a structure that is almost similar to Unix or Java, but it is less complicated and has a lot of vocabulary that you will see and able you to apply and develop. Our packages, as I said, is idea that we all contribute to the popularity of R. This is our job to make it more popular and to allow other users to test our program, to test our analysis, to test our code and see what we can do better. So how are we going to conduct this class? We're going to learn different statistical theories, different statistical analysis modules, and we are going to use it by looking at two applications, the RStudio and the R console. Those, when you install the RStudio, you need to install the R console because this is part of how it runs. So in getting started, you loaded the console, you download it from the RStudio website, and it will look like a DOS prompt that you're going to run. In the RStudio, you're going to download the software, not the server, the software. The server costs money, and so you're going to download the server and you're going to develop it. It will look something like that. If you have problems with a software or your computer is a little bit old, nowadays the RStudio has a cloud environment that you need to register. Usually if you have a Gmail account, it will accept and it will give you the ability to run the code on the cloud. The issue with that is sometimes it's slow, sometimes it's not efficient. I highly recommend that you download to your computer. It will run faster. You'll be able to do more tricks and ideas, but this is up to you to decide how you want it. Before that, so we have 4 windows that we're going to learn how to use. We have a script editor. We have the R console that we install as a DOS. We have the view variable worksheet that you can upload data and run it. And we have the files, the plot, the managing, or the packages that we can use in order for us to generate our analysis. Example, when we're going to learn about I'm running out of regression. So we will apply different regression packages that designed to help us, example, to find data that fit into the regression and will give us the formula or common formulas that runs regression. So we will not need to run the analysis or to write the code ourselves. It will give us the idea. However, this is something that you will become familiar throughout the semester. So the question is, are you ready for it? And I hope the answer is yes. That's it for the first module. I hope you enjoy it. I hope that you will keep in the class. And if you have any questions, your job in this class is to ask questions. My job is to answer. Have a great semester and let's have a great fun in statistics and R. Until next time, have fun.